Good morning, good morning, good morning. Welcome to day 2 of Connect Tech. I hope you all enjoyed day 1. Yeah? Good. I got 2 whoops. All right, still early. So a couple of years ago, I went through a kind of professional identity crisis, right? So I call myself a front-end engineer, but I wasn't doing any front-end engineering, right? Or typical UI engineering. Like I wasn't writing any React code, wasn't writing any CSS or HTML, was never visiting localhost on my browser or anything like that, right? So I work on a front-end platform team, so am I a front-end platform engineer, right? It kind of doesn't roll off the tongue. So what I want to do is kind of walk through my self-discovery of how I figured out kind of a way to describe myself, who I truly am, all right? So, yes, I have the slides up for this already. So if you are interested in getting the slides, I'm gonna have tons and tons of links throughout it. So feel free to capture this QR code, right? Some of you are like, Ben, this is slide 2. I don't even know if I want these slides yet, right? But if that's you, I mean, that's your decision. But I'm sure you're going to want it. That's just my personal opinion. But if you don't, if you find out later, you know, slide 10, slide 11, I also have a link at the bottom there if you can see it. So you'll always have a way to find the slides. Raise your hand if you think call yourself a platform engineer. All right, I got a few. Oh, I even got some of this. Okay, yeah, you're unsure. Well, I promise by the end of this talk, you will be sure. Either way, all right? My story, personal story, begins 20 years ago, all right? When I started doing web development when I was a teenager in high school. So I'm completely dating myself right now, but that's okay. When I first started, right, I used to write actual HTML. Right, in an editor. And I would write some actual CSS and include it in that HTML, writing an actual link tag. Like blows my mind now that I never have to do that again, but that's how it worked. If I wrote some JavaScript, I would include it with an actual script tag right there to the file. And if anybody recognizes that code inside the HTML, it's a spacer GIF. I don't know who was around during that time, but if you were, we are some true OGs right here having to deal with that. But it was the wild, wild west. Like my HTML is in all caps for some reason. I don't know, but that's what we did. I call it the good old days, but they are actually pretty terrible given what we had to do in the browser. I had to support IE4. That just puts that in perspective, okay? So things were pretty bad, right? So jQuery and Ajax entered the chat at this point, right? So for those who don't know, Ajax stood for asynchronous JavaScript and XML. XML, right? So supposedly we're supposed to get data back from fetches in XML, but we quickly ditched that for JSON. So now it was a lot easier to make interactive pages, right? Because jQuery smoothed over the differences between browsers. Like browsers didn't even agree on how to make API requests. Like now we have the fetch API, but back then that didn't even exist. IE and Netscape and all of those, Mozilla disagreed on how to do that. And they disagreed on how to even attach events to DOM elements. So jQuery came in and helped us out. And during that time, there was Moo tools, if you heard of that, YUI, Scriptaculous, like all of these, Dojo, all kinds of throwback tools. But ultimately, we wanted to make more. I wanted to make more sophisticated UIs. So that led to the first Framework War 1. And it focused mainly on being able to create browser interactivity, right? So all of these tools, they were called MVC frameworks, right? Because they borrowed this design pattern, model, view, controller from the back end. So if you were writing Java or .NET, PHP, Perl, all of those tools, they were MVC models, and they're like, okay, well, let's bring that to the web now, right? So kind of a show of hands, how many people think they could name all 10 of the logos right there? You know, you see all 10? Okay, I'm going to name them for you. So there's AngularJS, not Angular, AngularJS, EmberJS, Backbone, XJS or Sencha.js, Knockout, that's the top row, Polymer.js, forgotten about that one, Meteor.js, Bootstrap, Foundation UI, and then jQuery UI. All 10 of those. Those are all competing different frameworks for building UI back then. But there was no NPM and there was no GitHub at the time when I started, right? So the way that I would get these libraries is I would go to the website, download a zip file, unzip that into my repository or my code base, and then put it in a vendors folder that I then included in a script tag manually on an HTML page. Like, that's how it worked. Like, I was my own bundler, effectively, okay? It's unfathomable now, but that's how it worked back then. And then, so the industry needed a way to manage all of these JavaScript and CSS tools that we're starting to use. We needed a way to store and retrieve it with a registry like NPM. We needed a way to minify it and bundle it, which became Webpack. Needed a way to test and verify our code, which became ESLint and Webpack. We were transforming from ES5 to ES6 or ES 2015. So there was a tool called 5 to 6, right? If anybody remembers that, which ended up becoming Babel. And we needed a way to run all these tasks there. So this is where I started to slowly move away from UI and started working in a Node environment as well. So as a result of that, we now became in the second framework war, okay? This one was all about UI frameworks, but instead of like all-in-one frameworks, we started to separate things into different libraries around UI, data, that sort of thing. Because this is now where the front end was getting more complicated. So hopefully people can recognize more of these here, right? So we've got Angular and React. Those are easy to identify. Redux, Vue is probably easier. Svelte, and then at the bottom we got MobX, RxJS, React Router, Relay, and Apollo. All tools were being used there. But these focused mainly on the UI. So now we're in what I'm calling Framework War 3, all right? Which is less about the UI and it's more about the development or deployment environments, which I call meta frameworks because they're frameworks of frameworks, essentially. So they're trying to abstract all of that non-UI stuff I was talking about from the previous frameworks that they all created. So what's interesting though, I find interesting at least, is that they're all moving to other languages like Go and Rust in order to make things a lot faster. So SWC, that's one of them. It's now a Rust-based platform for the web. Some of these hopefully are more identifiable for you, right? So we got Create React App, which kind of started it all off. Next.js and Gatsby, Astro, which I'll talk a little bit about later, Remix, Nuxt for Next, Vite, SWC, Vercel for deployment, and Netlify as well. All right, so if you do get these slides, like all of these logos, they're all linked, so you can click on them, go to the page and find out more about whatever tool that is. So my good friend, Jonathan, over here, he sent out this tweet 3 years ago, I think now, about how maintaining complex front-end build systems is serious work. So like, what do we call ourselves now? So we began to call this fusion of front-end and DevOps-y type stuff, Divops, as a play on words, right? Hopefully you all are getting that play on words there. So it's kind of like all of this work that front-end engineers do in part, or maybe totally do, to maintain front-end infrastructure. So unfortunately, I can't take the credit for DevOps. Enrique here is actually responded to that tweet and came up with DevOps, kind of moved it around to make it look like an HTML tag, so it's a little bit cooler there. But even though I didn't come up with it, I've been broadcasting it everywhere to try to, legitimize it and such. So let's talk about it. But first, can I get everybody to stand up? Real quick. Okay, so it's the beginning of the day. We're a little bit tired. I've already seen 3 yawns as we begun. So what I want to do to wake us up is that we're going to do 10 squats just like that, okay? I'll count us out, don't worry. And if you don't want to do it, you can totally not do it, or you could just use your arms or whatever. But we're going to do 10 squats. And since this is a front-end conference, we talk a lot about JavaScript. I'm going to make this 0-based. So I'll start with 0, all right? And we'll make it happen. You guys ready? Here we go. 0, 1, that was weird. 2, 3, yep, we're doing it. 4, halfway there. 5, yeah. 6, somebody's doing it with their coffee. 7, 8, almost there. 9, and, oh, caught y'all. Aha, off by 1 error. I see you. Aha. Aha. All right, formally introduce myself. My name is Ben Ilegbodu. I'm a Christian, a husband, and a father. My faith and family are super important to me, so I wanted to kind of shout them out. That's my wife, Rashida. We've been married for 13 years now. We celebrated number 13 last month. Appreciate it. Thank you. We have 3 kids. Oldest daughter, Simone, she is 9 years old. Our middle daughter, Avery, she just turned 7. And Mr. Pouty Face there is our son, Asher. He is 4 years old. We live in Houston, out in a suburb called Manville. I used to live in the Bay Area, and we just recently moved back to Houston. And I'm a huge basketball fan, okay? I love to play basketball, watch basketball. I'm a Rockets fan, being from Houston. It's been difficult the last couple of years, but that's okay there. So since we're from the Bay Area, all my kids grew up in the Bay Area. I still try to indoctrinate them on the Houston Rockets. But you can guess which one hasn't followed through. So, you know, I love all of my kids, but I love 2 of them more. Okay? So I'm a Google developer expert in web technologies. If you've heard of the GDE program, I'm also a front-end architect at Stitch Fix. If you've heard of Stitch Fix before, we're an online platform, clothing platform. We mix together technology and machine learning and real stylists to send you clothes that will fit you and that we believe that you will enjoy. But enough about me. Let's talk about DevOps engineering. None of this will be talking about the UI, but everything around the UI. So first, let's talk about our development environment, how DevOps engineering supports development. So the first one are compilers and transpilers. So transpilation is taking JavaScript code and transforming it into some other JavaScript code. So generally it's new JavaScript or it's TypeScript, and we're changing it to the version that the browser or node or whatever interpreter can handle. So Babel is the main one here, or has been the main one in this space. Technically, TypeScript can take your TypeScript code and convert it into JavaScript, but typically we use Babel for transpilation and then TypeScript for type checking, which I'll talk about later. But there's also this Rust-based SWC, which is getting super popular now for handling transpilation and such. This last logo is Google's Closure. Technically, it's a transpiler. I don't know anybody who is using it now, so if you are using it, please come tell me. I would really like to meet a unicorn developer. All right, so just let me know. All right. So then, kind of in concert with compilers are bundlers, and they take all of our different JavaScript and CSS and put it into 1 or 2 bigger bundles because we can't include all of these JavaScript files on a page. So Webpack has been the one for many, many years and such, but its configuration, if anybody's had to look at it or edit it or write one, is like ridiculously complicated, right? So somebody has to do that, right? Somebody has to configure it. You're not going to have your DevOps engineer or your backend engineer doing it. So now you have a front-end engineer having to figure out how to configure their development environment, right? So that is different than UI engineering, different than backend engineering. I'm calling it DevOps engineering, right? So in this space, there's also Vite, which is super popular now and much faster, or they say they're 20 times faster than Webpack. There's TurboPack, which just recently was announced, I don't know, 6 months ago or something like that from Vercel, and some other options there. There was Roam and Snowpack, I believe, that was also in this space, but they have now gone out of business, or however you want to describe it. So it's super important to hitch our wagons to something that will last. So that's another decision that DevOps engineering has to make. Not only do you have to figure out how to configure one of these tools, but you also need to investigate all of them to figure out which tool works best for you. And then, because of all of this complexity I just described with bundlers and compilers and type checkers and all that stuff, there have been all of these meta frameworks that have come out to try to abstract all of that away so we can focus on our UI again. So we have Next for React, that's a popular one, or Remix if you use that. There is Nuxt for Vue. There's a new one I just heard of called Analog for Angular development if you do that. They're all similar. There's SvelteKit for Svelte, obviously. And then there are other tools like Astro and Vite that will work with any of your UI frameworks. So those have become really popular there. So not only do they solve the UI framework problem, but they also handle server-side rendering, routing, styling, like all of these things that we had to cobble together with React Router or other tools in order to make them happen. So like I said, their goal is to abstract all of the DevOps-y type things. And look at that, there's so many different options that we have to choose and pick from. But there's even more. So once we get past all of the compiling and bundling, front-end engineers had to figure out how we're gonna make API requests. Like how are we gonna contact or work with GraphQL? Are we gonna use the Fetch API? Are we gonna use Apollo or Prisma for a database or ORM? Are we gonna use Firebase, right? So maybe, well, hopefully the DevOps engineer will set up the Firestore or set up Firebase authentication or the backend database, whatever we use. But I wouldn't be surprised if a front-end engineer has to set it up too. I know when I'm working on my own stuff, I have to set it up. So you have that. Then, if you have a company, and most of you probably work at companies, and it has its main app, but it also has a blog, it also has a marketing site, and maybe they all share a component library together. Instead of having these in a poly-repo architecture or multi-repo architecture where you have to jump around, you can put all of these into a monorepo, right? So that they can all share the same versions and have that benefit. But then that requires orchestration to make sure that's performant, you're not building too many different things, all of that. So there are tools to do that. You can use NPM or Yarn or PNPM. They have workspace setups, but then there are also tools on top of those like Lerna, NX, Turbo Repo that we can use, that we have to set up to make sure that the remote caching is working, that it's fast in CI. Like there's all these little things that create, that enable development to be better, faster, easier, so that the UI can work, but this is all extra configuration that now somebody's got to do. It's probably a front-end engineer, and they're probably doing DevOps engineering. It all falls on us as front-end engineers. Okay, one more on the development environment. So there's JavaScript that most of us write, and we write it mostly for the browser, but we can also write it for Node and command line scripts there. So this is JavaScript that we're writing in Node, but it's not like a Express server. It's stuff that we're running on the command line. So these are like the equivalent of writing, let's say, a bash script, except you don't have to bash your head on the wall trying to figure out how bash scripts work, right? You kind of glue everything together, right? So this could be setting up your mock data environment, right, for local API development or to make API calls. If you've ever used Firebase Emulator Suite for Firebase, or if you used mock service worker, for instance, that all has to be set up in your development environment, right? So that people who are developing locally can actually work locally, because we kind of take for granted sometimes, like being able on the front end to work in a development environment and run the app locally. But I know so many companies, so many teams that they can't even run their app locally because of all the different services and how interconnected things are. They have nobody who's around to be responsible for making the development environment work. So all of this, just this part that I've talked about with the development environment, is super important to have working. Okay, so that was the development environment. Let's talk about the static analysis environment, which comes next. So I don't know, I'm not really deep into other technical communities like Java or C# or .NET rather, but I really appreciate how in the front end community, static analysis is actually like a huge emphasis in it. So these are tools that help us keep our code consistent or help us even catch errors before we have to run it in the browser or in Node. So we have linting and formatting first, and they kind of go hand in hand. So ESLint and StyleLint are for JavaScript and CSS. They're like the major players in this game, so to speak. If I was talking about this 4 years ago, would mention standard.js or TSLint, or if you've ever heard of JSLint, which was even before that. But now pretty much everybody uses ESLint for linting. And then for formatting, there's Prettier, right? So it's kind of like linting. It's kind of a combination of a compiler and a linter, because it does transform your code like a compiler, but then it's mostly around stylistic choices, so it's like a linter in a sense. But the interesting thing about Prettier is that I use it in VS Code, and I've set it up so that when I save my file, it will prettify it right after that. So now it's created this kind of feedback loop that if I save and my code doesn't get formatted, I know that it's broken like structurally somehow. Like I'm missing a parentheses, I'm missing a curly brace, I've done something wrong, so that I know that I need to check it before I even run it anywhere or run tests or stuff like that. And then those last two at the bottom are Husky and lint staged. So if you're not familiar with those, what they do is they use Git hooks so that you can run linting or maybe testing when you are committing your code, so that you can get the lint errors before you even check code in, which is super helpful there. So then lastly, or next one I want to talk about is type checking. So I don't know if there's anything out there really besides TypeScript. Like I know Facebook or Meta uses Flow, but I don't know if it's actually useful outside of that organization. But anytime I have to go into a JavaScript only environment now, like I just feel so unsafe, I guess I'll call it. Like it's like, can this thing be null? I don't know. Like what properties are on this object? Do I have to follow some comment that somebody wrote 2 years ago that might have gone out of date? Like it's so difficult now being so used to TypeScript. But like I mentioned, I don't use the TypeScript compiler to transpile. I only use it for type checking. And again, I combined that with VS Code so that I get all of the little squiggly underlines as I'm writing my code and get that feedback there. So learning TypeScript, though, it has a huge learning curve, in my opinion. Like, I've been using it for 5 years, and I'm still learning new things about TypeScript as it evolves. In fact, I don't know how many people were here yesterday. I was in Waller's talk about TypeScript, advanced TypeScript, and I learned about the infer keyword just yesterday. So there's lots and lots to learn there. And there's lots and lots of TypeScript, or lots and lots of configuration for TypeScript. Like, this is a TypeScript config, and this is a TypeScript config that I copied, because I have no idea, or I have very little idea of what all the properties do, right? Prettier has a very small config language, but TypeScript is like crazy ridiculous. So we're now asking a front-end developer to figure out what all of these things mean so that when we write our TypeScript, we're not getting type errors because we misconfigured it, right? So there's nothing worse than having to fight a type system because it's incorrect. Like, we want to make sure that it's not complaining about some node module that was typed incorrectly, so you have to set other properties, right? Like, even ChatGPT doesn't know how to configure TypeScript well, right? So I'm sure there's somebody in here who's looking at this configuration and pointing out a couple of things that I did wrong, right? And my response to that is, yeah, I probably did do it wrong. But if you know some things to figure out, just let me know. Okay, so development environment, static analysis environment. Let's talk about testing, right? Because testing is important. We should write tests, all right? And my thought is that the earlier we put test environment and set that up, the healthier our code will begin and continue there. So let's take a look at what DevOps engineering looks like for the testing environment. So first, we got unit testing, which is the most common form of testing, right? So there are a number of platforms here. There's Jest, there's Vitest, I think is how it's pronounced, Mocha Chai, which is also common there. But at this point, the only two legitimate ones are Jest and Vitest. That's what I'm seeing a lot of people use. And just like Babel, just like Webpack, just like ESLint and TypeScript, there are this huge configuration language just for setting up a test environment. In fact, here's the Jest config. So, technically you can use Jest 0 config without setting anything up, but in reality, you really do have to customize a Jest config. And I went to the configuration yesterday, and I looked at how many different things you can configure. And there are 70 different fields you can configure for your Jest config. And that doesn't include all of the presets and plugins and transforms that you can do and escape hatches that it provides, right? So, like, who's gonna figure that stuff out? Like, this has nothing to do with writing a use effect hook in React. It's just like completely different. And you want to make sure that you can test the use effect hook in your React code. So this all needs to be set up there. So it takes a certain skill and interest to really want to be able to set this stuff up, right? And not everybody has that skill, and certainly not everybody has that interest to even develop that skill. So we've got unit tests. Then on the complete other end are end-to-end tests. So this is running our UI, our app, or whatever the case may be in a real browser situation, right? So we want to validate what the UI ultimately looks like, not just input and output of functions, but what it ends up looking like to validate the user experience, let's say. So there are a couple of options in this space that we would need to set up or pick from and then configure, right? So there's WebDriver.io. That's built on top of Selenium, which has kind of been the tool that's existed for a long time, I should say. Cypress used to be the darling a couple years ago now, but it seems like everybody's moving towards Playwright as a tool. I haven't used it yet, but I've looked through the API and it just looks a lot easier than Selenium for sure. and some of the other tools. So if you are trying to introduce end-to-end tests into your platform, I would totally suggest looking at Playwright. But again, of course, you got to configure one of these. You got to pick which one you want to use based upon your team's experience, what kind of languages they work on now, because they each kind of target a specific flavor of writing code as well. So then the last thing in the testing place I want to talk about is visual testing or visual regression, right? So in this area, it's also called maybe snapshot testing as well. So what happens is you take a picture of the app or take a picture of your storybook components, and then it will compare that after you make your changes to see if anything has changed, right? So you can set up a storybook app to do your development of components or isolate your components. But if you're building a component library, it could actually be your documentation and your actual development environment as well. The second one there is Chromatic, which is built by the Storybook people, I believe, and is a visual regression tool that you can use. Percy is the one that I've used. It's purchased by BrowserStack, actually, and BrowserStack allows you to run tests on like physical devices. Like they have a device farm. You say you want an iPhone 12 with iOS whatever, and it'll run your app on Safari on that phone in that operating system. Or you have a MacBook and you want to see what it looks like on a Windows machine running Edge and Windows whatever. I was going to say XP, but no, I don't think it goes that far back. So those are all that is pretty cool. You just hook it up with GitHub, and it'll run those tests. And you can set up like browser widths and all those sorts of things. But again, you got to configure what your test matrix is going to be there. All right. So we've already covered a lot, right? Let's recap. We talked about the development environment. We just talked about testing and static analysis, right? So those three things so far. Number 4 I want to talk about is CI/CD. So a quick aside, actually, I want to tell you a story. My first job out of college was in 2006, and I worked at this startup, which I will not name, but if you go to my LinkedIn, you'll figure out who it is. We didn't write any tests, like nothing, no testing environment. We didn't do continuous integration. We didn't do continuous deployment, like none of that. We would just ship code every 2 weeks, right? So you can imagine what it's like trying to ship code every 2 weeks that was never tested, that was never continuously iterated, right? It was a complete nightmare. We would have like everybody hands on deck, let's try to release this code, and everybody hands on deck after we release this code. You got to be ready to make sure stuff doesn't break or catch whatever is broken and that sort of thing. So this is where like front-end engineers really get out of our front-end space, right? Although like CI and production, they do apply to like other services, not just front-end apps. So hopefully this is where the DevOps folks will step in, right, and handle setting up your CI environments and CD environments and such. But it may fall on the responsibility of DevOps engineers to set things up, especially when we start talking about NPM and things like that. Up until now, everything's been running on our local machine, right? Development environment, you can run tests locally, lint locally. But once we get into the continuous integration environment, we're somewhere else, right? So you can use GitHub Actions, right? GitLab CI, Circle CI is another option for continuous integration. Jenkins is a huge one. So when we're using any of this, that means we're running YAML for GitHub Actions. We're using YAML for Circle CI. We're using YAML for Jenkins CI. Like, I don't know what the deal is with YAML and CI systems, right? But Jonathan was just mentioning yesterday that he's basically a YAML engineer, right? That's all you do is just write YAML all the time. And the thing about YAML, I don't know if anybody else feels this way about YAML, but I still cannot wrap my head around the language of YAML. Like, I try to think of it as JSON, but then it's indented, and sometimes there's 2 levels of indented, like you have to use a colon. Like, I don't quite get it yet, so I just always copy and paste. And that tells me what the answer is. If it doesn't work, then I try again. I just, new tab, let me add more tabs to see if it'll work there. But the CI environment, it's running all of our static checks that we talked about. It's building our apps with Webpack or whatever that we talked about. But this DevOps engineering is also setting up pipelines so things can run and be cached or run in parallel so that we can have test sharding because we have too many tests and we got to make sure that they can run in parallel. We got to send stuff to browser stack so it can run the end-to-end test or the Percy so it can run the snapshot test. Like all of this kind of stuff in the YAML configuration, somebody's got to write it, right? And it's not going to be the DevOps engineer because it's all around the front-end code. So that also is DevOps engineering. So if you find yourself doing those sorts of things or maintaining those types of files or editing them, you're actually participating in DevOps engineering, right? So you got CI, then you got the CD. I call it continuous deployment. I think it also could be continuous delivery. Hopefully those 2 words don't mean something different, but I use them interchangeably, right? But now we're on the fringes, personally, of my experience, right? I want to hand this off to DevOps engineers and like, you figure out how this thing should be served to actual clients, right? So these tools that I've listed here are just names of tools that I've heard people say, okay? So there's Docker and Nginx. I kind of know what those do. Docker containers, Nginx serves static site. There's AWS, right? There's Google Cloud Platform, GCP, Azure over here, Microsoft that deploy clouds. There's Kubernetes and Terraform that do things. I've heard that lots and lots of times. I think I don't know. Then there's also content delivery networks, CDNs, heard of those? Cloudflare, Akamai, and Fastly. Those 3 things have been used at my last 3 companies. So, try those out, I guess. I do know they put things at the edge, so things are faster, because the edge is faster. That's the extent I know about the edge, okay? So, hopefully DevOps engineers do this part, because I don't know how to do and roll all these things together, which is why I use cloud platforms instead. So I will use Vercel or Netlify or Firebase hosting to handle all of these different things. And I'm assuming they use Kubernetes or they use Docker or AWS in order to make it happen, but I don't have to worry about it, right? And that's the promise of them there. So you deploy to main, and then they'll run your build scripts, and then magic, and it's deployed out there, and it's using the CDN, and it's super fast and stuff like that there. So I'm trying to remember, that's Heroku at the bottom, and I'm trying to remember what the last 2 were, but I can't even remember what they were anymore. Anybody know? Think of it? Well, it's Dark. Oh, yes, Launch Darkly, and what's the other one? I just met somebody whose company is there. So Harness, yes. I just met Chris, who works at Harness, so I put that up there for him. I only knew about it 2 days ago. All right, so CI/CD, right? There's so much to learn about CI/CD that Jeremy's actually giving a talk about CI/CD. So if you're interested in these sorts of things, actually, I probably should go to the talk so I could be more familiar with CI/CD. So it's happening later this morning. Okay, last thing about CD. So we talked about apps and delivering those, but what if you're working on packages, right? You need to deliver those to NPM or release them to NPM, right? So there's kind of 2 forms of thought with package releases. I think the more common one is that people make changes, and then eventually you release a new major version. Or you make some fixes, and then eventually you release a dot version, or then you have a breaking change, right? V13 of Next.js, for instance. But how many times, actually, have you filed an issue or seen an issue in a library, you see that it got fixed, surprisingly, and merged into main, but they didn't release the new version of it. And you're still waiting for it. And it's like, come on, like release it, right? So there's another school of thought, which is like continuous release. And there are tools that support that, so that anytime you merge into main, it will release a new version based upon how you've defined what the change was. So semantic release is a tool that you can use that does that. You just label using the commit format. You just say fix on the commit, and then it'll dot release it, for instance. So they say they want to make releasing unsentimental and unromantic. It just happens. However, semantic release doesn't really work with monorepos. Remember, I was talking about monorepos before. So if you're using a monorepo, if you're already using Lerna supports this. So it has its own release setup there. So you can release multiple packages with the same version, or if multiple change and they have different versions, you can handle that. There's also change sets, which is a library that just does releasing. I use that. It's pretty sweet in how you can describe the changes there. I don't really want to go into ESM versus CJS if you've had to deal with that sort of configuration and how you do that in your package JSON to make sure that if people are importing in Node, they can use it. If they're using a modern bundler, they can use that with code splitting and all that stuff, tree shaking. That's a whole thing and really a complicated thing with DevOps engineering. All right, last section I want to talk about, which is production. Okay, so after we've delivered it to the website, the work doesn't stop, because now we got to figure out how our clients' experience is, how they're interacting with the app there. So the first section is analytics, right? We need to be able to understand how they're using our app so we can make business decisions based upon what's popular, where people are dropping off, et cetera, et cetera, et cetera. So Google Analytics is the obvious choice there. Apparently Cloudflare has an analytics tool that you can use. I Googled some more. I Googled Google Analytics alternatives, and I found these last two, Plausible and Matomo, I think I'm gonna call it. They seemed really popular. People use it and stuff like that. So someone's got to set up the back end of that, but then we as front-end engineers need to actually instrument it into the code, add script tags and whatnot. And then there's monitoring, right? Which may be even more important than analytics, really, because we need to know when something is going wrong with the app. So something's broken on the page, they're getting 500s, whatever the case may be. So you can use Bugsnag for that, or Sentry for that, Crashlytics from Firebase. Like, they all effectively do the same thing. So we got to figure out which ones we want to choose, basically. Typically, the companies I've worked at, the client-side tool we use, Bugsnag or Sentry, it depends on what the backend is already using, if they're using Bugsnag or Sentry, essentially. So that's the first category. And then the bottom category of monitoring is like logs and tracing to be able to debug when something has happened. So you can use Datadog or New Relic and those sorts of things. So hopefully the DevOps team sets those things up, but of course we got to integrate them into our apps. And then last but not least is performance. I had a former coworker who says performance is a feature, right? It's not something we just do, but it actually can improve our app. Like, there's all of this research that shows that if we make something respond faster, we get better conversions. Like, more people spend money, more people click such and such, like that sort of thing. So Lighthouse and Page Speed Insights are a perfect example of tracking performance manually as you're running in your browser potentially. But there also is Lighthouse CI that we can run in a CI environment. Then there's full SaaS tools like SpeedCurve that I listed there, which that company just does real user monitoring. So they'll know exactly how long it's taking for first contentful paint, for instance, those sorts of things. And then all of the mega monitoring tools like Datadog and New Relic have their own RUM versions too. And because this is entirely on the front end, typically front end engineers are setting those things up. Okay. Wow, that's a lot. We talked about a lot of things. So this recap are all the tools that I typically use or want to use soon, right? So I'm gonna try, there's 21 here. I'm gonna try to name them all. So we've got Babel, TypeScript, Vite, Apollo, Node.js, Turbo Repo, Webpack, Prettier, Jest, Playwright, Storybook, Percy, GitHub Actions, Vercel, Change Sets, Google Analytics, Bugsnag, Datadog, Lighthouse, Web Page Test, and Page Insights. All of those things. Look at that. I got it. All of those things you got to set up. All of those things are necessary, really, in order for a web app to be successful and to be high quality, and that need to be set up, right? And this doesn't include like setting up Tailwind or Material UI component library or whatever component library you use, right? All of this is, none of it's UI, but it needs to be set up in order to support the UI, right? So this is what DevOps engineering ends up looking like, all right? So I asked in the beginning, who is a platform engineer? And I got some, so now the question is, who's doing platform engineering based on all the stuff that I just described? Who's been doing any of those things, right? Look at that, all these hands now. 75% of us now realize that we're DevOps engineers, okay? Or we're doing DevOps engineering at the very least if we do it sometimes, right? So if you're sometimes doing UI, sometimes doing DevOps engineering, you are now all full stack engineers, okay? But different full stack engineers now, right? So it's just in a different direction. So the whole reason why I wanted to share this, the whole reason why I wanted to talk about this is because I want to legitimize this kind of exercise or this kind of field of development, right? So personally, I was afraid to do it. I wanted to stay in my UI development safety bubble, right? But eventually this stuff had to be done. Like somebody had to figure it out, somebody had to do it. And I stepped up once, I configured a Babel config, and I didn't die. So I was like, all right, let me try Webpack. And then I was like, all right, let me try TypeScript. I don't know, but ended up just doing one after another after number. Started getting confident in doing it or comfortable in doing it that, okay, I can figure these things out. So I want to encourage everybody here that you could do it too as well. It's not janitorial work, right, that you have to do to get out the way so that now you can build the UI, right? It doesn't have to feel like a tangent, like, oh, now I got to make this TypeScript config work, or I've got to configure browser stack to do whatever. Like, it's a legitimate field of front-end engineering, right? So I want to bring awareness to that. Like I said, I want to legitimize it. And my ultimate goal, well, I would say first step goal was to be able to do a talk on it. And Pratik and Vincent gave me the platform to do that, so that was successful. But the next one, the ultimate goal, is to have a job description that says DevOps engineer, right? So there are people like Microsoft, they're hiring people who are specifically doing this type of work. But I don't know what they call them at Microsoft, but I'm sure they don't call them DevOps engineers yet. But it's going to happen. Jonathan and I are going to partner. We're going to make sure that works. So one day. And then lastly, I wanted to share that there is a DevOps community that's small, but that's growing, right? So there's a Twitter hashtag, Divops, which is mostly me talking about DevOps so far, blog posts and stuff. There's a subreddit that you can go to for DevOps there. And then the best place you can go to is our Discord server, where folks are in there talking about, like, how do I configure this? Or I want to set up my monorepo to do that. How did you solve this kind of problem, right? We're all running into these issues, right? ChatGPT can only do so much, right? We need somebody who can actually help us, who's been through these things and can guide us, or guide us away from something, really. Like, I did this, it didn't work. Go use this tool instead, right? So feel free to join the party. You can click that server link, click the icon, it'll take you to an invitation, and Jonathan here will accept your invitation. There. Okay, so that was a lot. Hopefully you learned a thing or two, maybe learned about a new tool that you had never heard of, new options that you can use, right? I list all the things that I knew about or had heard, but I could use your help too. If there are any tools that you felt like I missed that are super popular, I use this, it's great, feel free to let me know on Twitter or come chat with me. And if you've noticed, I included that QR code again for you doubters in the beginning who didn't think you wanted the slides. You still got a chance to get them, okay? So if you've got any further questions, feel free to talk to me at the conference. I'll be around and such. Or if you don't like to talk to people in person, that's totally cool. You can chat with me on Twitter/X. All right? I want you to enjoy the rest of the conference. Enjoy day 2. Thank you very much.